Imagine for a moment that your computer is a bustling city, and at the heart of that city lies a powerful engine, the CPU, or Central Processing Unit. This is where the magic happens, where all the calculations and decisions are made. The CPU is often referred to as the brain of the computer, and for good reason. It processes instructions, performs calculations, and manages data flow, making it essential for everything your device does. Let's break down the main components of the CPU. First up is the control unit, or CU. Think of it as the conductor of an orchestra, directing the flow of data and instructions throughout the CPU. It tells the other components what to do and when to do it, ensuring everything works in harmony. Next, we have the arithmetic logic unit, or ALU. This is where the real heavy lifting occurs. The ALU performs all the arithmetic operations, like addition and subtraction, as well as logical operations such as comparisons. It's the powerhouse that executes the calculations needed to run programs and applications. Now, let's talk about registers. These are small, high-speed storage locations within the CPU that hold data temporarily. When the CPU needs to access information quickly, it looks to the registers first. They're like a quick access toolbox, allowing the CPU to retrieve and store data at lightning speed. Then there's cache, which is another layer of storage designed to speed up data access. Cache memory is faster than regular RAM and stores frequently accessed data and instructions. By keeping this information close at hand, the CPU can reduce the time it takes to fetch data, making your computer run more efficiently. Now that we've covered the components, let's dive into the instruction cycle. This cycle is the process the CPU follows to execute instructions. It consists of three main stages: fetch, decode, and execute. First, the CPU fetches the instruction from memory. Then it decodes that instruction to understand what needs to be done. Finally, it executes the instruction, performing the necessary calculations or data manipulations. This cycle happens millions of times per second, allowing your computer to perform complex tasks almost instantaneously. To enhance speed and efficiency, CPUs employ several techniques. One of the most effective is pipelining. Imagine an assembly line where different stages of production occur simultaneously. In pipelining, multiple instruction cycles overlap, allowing the CPU to work on several instructions at once. This drastically increases throughput and makes the CPU more efficient. Another technique is parallel processing, where multiple CPU cores work together to handle different tasks simultaneously. This is particularly useful for multitasking and running demanding applications, as it allows the workload to be distributed across several cores, improving performance. Understanding how a CPU operates is crucial because it directly impacts the performance of your device. A well-designed CPU can handle more tasks, process data faster, and ultimately provide a smoother user experience. Whether you're gaming, video editing, or simply browsing the web, the efficiency of the CPU plays a vital role in how quickly and effectively your computer responds. So, the next time you power up your device, remember the intricate dance happening inside the CPU. It's not just a piece of hardware, it's the core of your computing experience, tirelessly working to bring your digital world to life.